Hello, my name is Haley Zynda, and I am this year's Master Grazer intern. Today, we are going to talk about forages and their nutritional importance in cattle diets. First, we'll discuss what constitutes a forage, nutritional aspects of forages, and to finish, nutritional needs of beef and dairy cattle. Forages are grasses or legumes, like clover, that are eaten by livestock. This plant matter may be eaten fresh in a pasture setting, cured as hay, or fermented as silage. Grasses are typically the first thing that comes to mind when talking about forages. They can actually be further subdivided into cool season and warm season grasses. Cool season grasses do well in spring and autumn, but are typically dormant during the hot summer months. Several grasses that are commonly found in Kentucky pastures include tall fescue, orchard grass, and Kentucky bluegrass. In contrast, warm season grasses thrive during the hot summer months. They tend to grow rapidly and are most useful for pasture or hay production. Some are perennial, meaning they come back year after year, such as switchgrass and Bermuda grass. Others must be planted annually, like Sudan grass and sorghum Sudan grass. Some warm season grasses are even considered to be weeds, such as Johnson grass and crabgrass, yet they still provide forage for livestock to graze during the summer months. Legumes are the other half of the forage equation. They are unique in the way that they house nitrogen-fixing bacteria in nodules on their roots, and that allows the plants to be rich in plant proteins. Proteins are built from sequences of amino acids, all of which have a nitrogen base. The bacteria convert nitrogen from the air into ammonium, which is usable by legumes, and in turn, livestock. The most popular legumes that are seeded in pastures are white clover and red clover. But why is forage important in cattle diets? Cattle are ruminants, meaning they have a 4-compartment stomach, the largest of them being the rumen. In the rumen, there is a massive population of microflora that includes bacteria and protozoa. They are responsible for the initial microbial digestion of forages. Forage supplies a large quantity of fiber, much of which could not be utilized if not for the microbes. Lignin is another substance found in forage, especially in mature plants. It is the woody parts of the stems that provide strength, very much like steel reinforcing rods in concrete, but is indigestible by cattle. Fiber as a whole can be separated into neutral detergent fiber and acid detergent fiber, or NDF and ADF. Neutral detergent fiber is an indicator of voluntary intake, so when NDF is high, intake will be decreased. ADF is an indicator of digestibility. Lignin and cellulose are included in the ADF fraction, and when they are in high quantities, the digestibility of the hay or grass as a whole will be decreased. In general, the best forages will be low in NDF and ADF. Rumen microbes digest the structural carbohydrates, cellulose and hemicellulose, and create volatile fatty acids as a metabolic byproduct. These fatty acids are what is utilized by the animal. They are absorbed by the rumen and converted into glucose. Fiber is not the only nutrient that forage supplies. Non-structural carbohydrates, like starch and sugars, can also be found in grass and legumes and are a direct source of usable energy. The relationship between fiber and sugars is also interesting. They are inversely related. When fiber levels are high, sugar levels are low, and vice versa. Therefore, if you have animals that need to gain weight, high sugar or energy diets are preferable to high fiber diets. But while you may have pasture or hay, do you have quality pasture or hay? Younger plants are of better quality for both pasture and hay, as they are higher in energy and protein, lower in fiber and lignin, and have increased digestibility and palatability, which leads to increased consumption. Much of the time, increased consumption also leads to increased animal performance. With this in mind, hay harvest should optimize both quality and yield. The boot stage, which is just before you see the seed head, is shown to be that optimal time. And while the yield may be less than if the grass went to seed, the quality of a younger plant far surpasses a mature plant. As for silage, many of the same principles apply. As for cattle, both dairy and beef have about the same nutritional needs until they have reached the age to begin producing calves or are sold to market. Both begin their solid feed diet with pasture or hay and eventually graduate to supplemented concentrates in times of enhanced nutrition. When developing beef heifers for breeding at about 18 months of age, they need to be at 65% of their mature weight, and then at their first calving, 85% of their mature weight. It is in these instances that they require high-energy diets and plenty of protein for their growing calf and their own growing body. Once she has become an established cow in the herd, she will have 2 critical periods of nutrition per year, the first being in the last trimester of pregnancy when the greatest fetal growth occurs, and the second during early lactation. Dairy cattle also have high nutrient requirements during lactation. During early lactation, dairy cows will not physically be able to eat enough to keep up with their body's demands associated with lactation. Dry cows have lower energy needs and can be fed primarily forage-based diets. Target dry matter intake for lactating dairy cows is generally around 4% of their their body weight, of which 50 to 60% comes from forages. With less digestible forages, forage intake will be lower and more concentrates need to be fed. However, these adjustments may not compensate for the lower quality forages, leading to suffering of production and reproductive performance. As you can see, forage is essential to nutrition. With so many forage species available, producers have plenty of options for their cattle to maximize health, performance, and profit. Thanks for watching.